Hello everyone. This video is titled Section 2.5 Solving Linear Inequalities. In this video I will be working through the Knewton Alta assignment, Section 2.5 Solving Linear Inequalities. And just know that the questions that I am given in my video here might not be exactly the same as the questions you get. All right. But the objectives will all be the same, and the way you would do the questions would all be the same. So I'm hoping that watching me go through a Knewton Alta assignment and how I would type in answers, I hope will help you when you work on your own Knewton Alta assignment, section 2.5. Alright, so here it is. Now you're not going to see the word preview. Right? I'm an instructor here, so but this is what you're going to see, except the word preview. The title of the thing, section 2.5, solving linear inequalities, right, upper right corner. You have this mastery bar, which tells you how far along, how much of the assignment they have deemed you've completed or mastered. Then you have the question below, and above that the objective that question is on. So this question is on the objective, solve a linear inequality that requires only one step. And if you'd like to see other objectives, you can click on the down button here. Looks like there are 3 objectives in this assignment. And we're on this current one. And next to each objective, you see this little circle with a star in the middle. That tells you the progress on that objective. So when you answer a question correctly in a particular objective, this circle will start filling up. Now, you've probably heard me mention this before, don't just guess on stuff, because if you get things wrong in these assignments, it might bump the progress bar back, and it'll take you even longer to complete the objective and complete the assignment. Okay. Now I won't be using, I've shown these buttons in other videos. One instructor cheat, obviously you are not going to see that button, that's for me. But the more instruction button, I believe I have shown in a other video for your course. This is if you are, seeing an objective for the first time, or a question you're getting stuck on. Click on more instruction, and it'll take you to some material that's about, that'll hopefully help you be able to answer those questions on that objective, or videos to watch. Now, I am assuming that you have read section 2.5 of your textbook, your openstacks.org Intermediate Algebra 2nd edition textbook. Alright, so I'm just going to be going through and answering the questions and showing you how to do things, and then typing in the answers. Alright, so first question is on the objective, solve a linear inequality that requires only one step. So we have solve the inequality b minus 27 is greater than or equal to 3, and write the solution in interval notation using improper fractions if necessary, right? So what they mean by that is, if you have 5/4 as part of the answer, leave it as 5/4, not one. Don't write 1.25 or 1 1/4. That's all that means. Okay, so I'm going to go to a piece of paper with this inequality written out, and we'll solve it. Okay, so I've written that down here. Again, very easy. We're just trying to get the variable alone, and we're solving, right? So that means find all the values that you can replace the variable with to make a true statement, to make this left side greater than the right side, or equal, right? Or equal to the right side. All right. Well, this is one step. In order to get this variable of b alone, I would just simply have to add 27 to both sides. So now the left side of the inequality symbol would be just b. The right side would be 30, right? 3 plus 27. And the symbol is still is greater than or equal to. Right? Remember, the only time the symbol flips around is if you multiply or divide both sides by a negative number, or if you decide to switch the sides, right? Then the symbol will flip around. But adding and subtracting, multiplying by a positive number, that does not change the symbol. Alright, so there we go. We have solved this inequality, right? This is a description, we got the variable alone. There's a description of all the numbers that make this statement true. So this means you could replace b with any number greater than 30, so like 31, 32, 33, 34 and a half, whatever, or equal to 30. 30 also works. Right. Now in some examples you might be asked to make a graph of the solutions on a number line. So I'll do that here. They told us to write the solutions in interval notation. I'll get to that in a second. So when I have, in my solutions here, I have 30 as mentioned, right? So remember there's 0 on the number line. 30 would be to the right of that. And then the solutions are all the numbers, greater than 30 are solutions, right? Like I said, 31, 32, 33, 34, all those numbers to the right of 30 are solutions. And then 30 itself is a solution, right? You have greater than or equal to. 30 is a solution. So that could be indicated either by a closed point, just a dot, a filled in dot above 30, or you might see in some books they put a rectangular bracket above 30. Right? The rectangular brackets mean that the number is a solution. Parentheses means that the number isn't a solution, or an open point, a hole, means that the number isn't a solution. So there's the graph, and then like I said, we were asked to write the solution in interval notation, and that'll involve the brackets or parentheses. Now when you're writing a solution set, when you're writing a set of solutions out in interval notation, you always go left to right on the number line. You always go low to high, low numbers to high numbers. So looking at my solution set, well, this picture here is the picture of my solution set. Right? There are the solutions of this inequality. And notice that this, going from left to right, this picture of the solutions here starts at 30. So I'll write 30 first, then a comma, and then what's the far right end, right? The far left end of the solution set is at 30. There is no far right end, right? There is no highest number in this solution set. So to indicate this, put the infinity symbol, right? Positive infinity. That indicates that there's no right end to the solution set. All right, then these get capped off with either a rectangular bracket or a parentheses, depending on whether or not that number is a solution. Well, is 30 a solution? Yes. We said that 30 is a solution. So you put the rectangular bracket. All right, rectangular bracket. If 30 wasn't a solution, you'd put a parentheses. Right? Infinity is not a number. Right? You always put parentheses on infinities. Right? So here is what they asked us for. The solution set, describe the solutions of the inequality in interval notation. This is what I'm going to type. All right, so going back to this here, provide your answer below. So I click on the open space there. I put I had a rectangular bracket, then the number 30, comma, then infinity. Now the infinity symbol should be, you can just click on it. There's infinity, and then parentheses on infinity. Right? Make sure you put in parentheses on infinity. There's the answer in interval notation as they asked. And then I hit submit, and if I did it correctly, it should say, great work or something positive. Right? And then it gives you an answer explanation. It gives you this answer explanation whether you're correct or incorrect. I would recommend reading it no matter what happens. If you get it right, read it just to make sure what you did fits with what they did, and especially if you're wrong. If you end up being wrong, read through the answer explanation and see if you can figure out where you went wrong, so maybe you can do better the next time. Alright, so now I'll hit continue. Alright, so this next question is still on the same objective, it looks like, and again, what I'm seeing isn't going to be exactly the same as what you're seeing. Yours may bounce around between the three objectives, but my next question is on the same objective. And you may notice that, hey, I got one question right, and now you see the little purple circle filling up. Also, see the mastery bar start filling up. Now I'm 8% complete with the assignment. Alright, so once again, I'll do this, right, on a separate sheet of paper. Okay, so here's that question written out, that inequality. To get z alone, I would only need to add 18 to both sides. Alright, so you'd have z on the left. I only did addition, so this greater than or equal to symbol will stay as greater than or equal to. Now you got to be careful, right? On the right side we have negative 2/3 plus 18. Now hopefully you recall from earlier math studies that when you add numbers, they have to have the same denominator, common denominator. Well, 18 would technically have a denominator of 1. Right? When there's no denominator, you can always put divided by 1, and it's still the same number. Alright, so these do not have, these do not have a common denominator. I need to get them to have a common denominator. Now hopefully you can tell that the least common denominator, aka the LCD, would just be 3 times 1, or 3. Alright, so I want to rewrite both fractions so they have a denominator of 3. The first fraction already has a denominator of 3. It's the second fraction I need to change. Now, in order to change it, I need to multiply the numerator and denominator by the same number. Now, in order to change the denominator into 3, I'd have to multiply 1 by 3. And if you multiply the denominator of a fraction by 3, you also have to multiply the numerator by 3. So now this right side is negative 2/3 plus, and then 18 times 3 would be 54. And then 3 times 1 in the denominator is 3. 54 divided by 3 is the same as 18, right? So I have the same value. That's why you multiply the numerator and denominator by 3, so you keep the same value. Alright, and now there's a common denominator. They both have a denominator of 3, and we're adding, right? That you need the same denominator when you're adding or subtracting. And when you add and subtract fractions with the same denominator, that denominator remains the denominator in the sum. So 3, 3, 3. You're only combining the numerators, right? The numerator of the sum would be negative 2 plus 54, right, which is 52. Positive 52. Right. And 52 over 3, 3 does not go into 52 evenly. 3 goes into 51 17 times, so this is 17 1/3. But remember, they said, use improper fractions if necessary. So I'm going to leave this the way it is, 52/3. That's the right side. Okay, so I have now solved the inequality, right? I've gotten the variable alone. And again, if I were you, I'd practice making graphs of the solutions on a number line here. So here's 0, and this is like I said, this is 17 1/3, 52/3. That would be to the right of 0. Right, here's 52/3. And all the numbers that are solutions, right, all the values of z that make this true are greater than 52/3. So that'd be 18, 19, 20, right, all these numbers, or equal to 52 thirds. So 52 thirds is included. So you have just a dot there, or the rectangular bracket. Right, then in interval notation, left to right, you know, the picture of my solutions from the left to right starts at 52 thirds. Sorry, 52 thirds, comma, and there's no right end, right? So to infinity, like in the first example. 52 thirds is a solution, right? So bracket on that. Infinity is not a number, right? So always parentheses on the infinities, and this is what we're asked to punch in, right? The interval notation for the solution set. So going back, I'll type that in. We got left the rectangular bracket, 52 divided by 3, comma, the infinity symbol right here, parentheses, and submit. Wonderful. Perfect. Your hard work is paying off. All right, great. All right, moving on. All right, see it bounces through the objectives sometimes. So see how this next question is solve a linear inequality that requires multiple steps to solve. But you're still doing the same thing eventually. You're trying to get the variable alone on one side and some number on the other. And my personal preference is to have the variable on the left side because it makes it easier to read and understand the solutions, I feel. Right? So once again, I'm going to write this inequality out, and once again they're asking us to write the solution in interval notation. So I'm going to write this inequality out and we'll solve it. All right, so big expression on the left, big expression on the right of this is greater than symbol. So first, I'm going to simplify the sides a bit. All right, so over here, got the quantity y minus 2 in parentheses. I'm going to distribute this negative 3. Right, that'll get rid of those parentheses. Now don't forget to distribute the negative 3, not just the 3. All right, you are subtracting all of this. Technically, remember, every time you see a minus, every time you see a subtraction, it's the same as adding the opposite. So this minus 3 times y minus 2 is the same as plus negative 3 times y minus 2. So that's why I'm distributing the negative 3. And then on the right side, same thing. Got this quantity 2y plus 4. I'm going to distribute the positive 4 here. All right. So we have 8y and then minus 3y plus 6, right? Negative 3 times negative 2 would be plus 6 is greater than, and then 2y, and distributing the 4, right? Plus 8y, and then plus 16. Right. And then combining like terms, the left side, 8y minus 3y is 5y. We have plus 6 is greater than, and 2y plus 8y is 10y plus 16. And then, as I said, I like to move terms so that all the terms with the variable are on the left and all the terms without the variable are on the right. So in order to do that, I would take away the 10y from the right, subtract 10y, and do the same thing to the left side. And that'll put all the variable terms on the left, and then get rid of the 6 on the left, right? So I'm going to minus 6 as well from both sides. All right. So after combining terms, we have 5y minus 10y. That's negative 5y. I was just doing subtraction, so the symbol still doesn't change. That still is greater than. And then over here, the y's are gone, and 16 plus negative 6, 16 minus 6 is 10. Alright, and then next, to get y by itself, it's being multiplied by negative 5, so I'm going to divide both sides by negative 5. Now here's where the symbol will change direction. Here's where the symbol will flip, because it's when I multiply or divide both sides by a negative number, which I have just done. So now I have y on the left is less than, right, flip the symbol because I divided by a negative, and then positive 10 divided by negative 5 would be negative 2. So here's a description of all the solutions of that inequality that we started with. So y can be any number less than negative 2. So negative 3, negative 4, negative 5, etc. Negative 2.1. Replace y with any of those numbers back in the original statement, and it should be a true statement, and I leave it to you to test that. For the graph, again, I know we don't need to make a graph, but I just like making them. So here's 0. Negative 2 would be to the left of 0. And all our solutions are, values that are less than negative 2. Right, so to the left of negative 2. Right, so like I said, negative 3, negative 4, negative 5, and so on. But only the numbers less than negative 2, not equal to negative 2. So negative 2 itself is not a solution, meaning I put a point, an open point, a hole above negative 2 that indicates that it's not a solution. Or you might see a parentheses above negative 2, and then all the numbers to the left. Either one of these is fine. Then for interval notation, again, look at the picture of the solutions. That's this picture here. Right, this arrow that I made, this graph. Going from left to right, see how there's no left end? Right, the solutions go to the left forever. So because there's no left end of the solution set, I'm going to indicate that with a minus infinity or a negative infinity symbol, comma. And then going left to right, this piece of solutions, the far right end is at negative 2. And then I cap these off with parentheses or brackets. Now, as I said before with positive infinity, negative infinity is not a number. So I put parentheses on that. That can't be a solution. And we said a second ago, right, negative 2 is not a solution. Right, so parentheses on that as well. And this, right, this is what we're asked to type in. This is what we're asked to enter, right, our solution set in interval notation. So I will do that. All right, so parentheses, negative, minus infinity, comma, and then minus 2, right, negative 2, and then parentheses again. All right, submit, and hooray, I did it. And let's move on. All right, answer explanations, of course, and then move on. All right, and the next question is on that third objective that hasn't been brought up yet. Graph an inequality on a number line and use interval notation. So this one, just, again, read the instructions. Express this inequality using interval notation, right? So not as a graph, but we can graph it and then write interval notation pretty easily. So once again, I'm going to go to my piece of paper. Okay, so here was the inequality that was given to us. X is less than or equal to negative 12/100ths, right? Negative 0.12. This is already solved, right? The variable is already alone. So if I were to make a graph, right, here's a number line, 0, negative 0.12, negative numbers are, to the left of 0, so I'll just put that here, at negative 0.12. And then I'll indicate what numbers make this true when I replace x with them. Well, this is saying that x can be any number less than negative 0.12, so negative 1, negative 2, negative 3, and so on, all the numbers to the left. Negative 0.13, negative 0.14, or negative 0.15. Anything to the left of negative 0.12 is a solution. Or equal, right? Or equal to negative 0.12. So negative 0.12 is also a solution. And you've probably noticed by now that when there's less than or equal, greater than or equal, you're going to have a close point or a bracket. And when there's just less than or just greater than, you're going to have an open point or a parentheses. Alright, so I've got the picture of the solutions. So then the interval is easy to draw. And again, just look at the picture of the solutions that I just drew. Go from left to right. Now there is no left end. So again, I indicate that with negative infinity. And then the right end of this picture of solutions is at negative 0.12. Negative infinity is not a number, so it can't be a solution. I put parentheses on that. Negative 0.12 is a solution to this, makes it true. So I put a bracket, right, one of those rectangular brackets on, and this is what they want us to enter, right, the interval notation. So I go back and I'll enter that. So parentheses, negative infinity, comma, and then negative 0.12, and then bracket, right, rectangular bracket. Submit. Wonderful. All right, let's continue on. So now we're still on this objective, graph an inequality on a number line and use interval notation. All right, now here's an inequality that's what they call a compound inequality. Right? It's two inequalities considered at the same time. And we're asked to plot the following inequality on a number line. And notice that this is one of those, this is an interactive example. And I'll show you how to work it once we do this on some paper. All right. And they explain to you how to work the interactive graph here. But I'll show you how to do it as well. All right. So let's go to some paper. Alright, so when you see a compound inequality like this, it's all it's two inequalities connected by a common middle part. This just means that x is between the numbers -5 and -1, right? So on a number line, and here's 0, -1 would be 1 unit to the left of that. -5 would be 5 units to the left of 0, right? So -5 should be to the left of -1, right? -5 is less than -1. And the values of x that would make this statement true, again, are the values between -5 and -1. Right? So just these numbers here. And then you got to be careful, right? -5 itself doesn't satisfy this, right? Because -5 is not greater than -5. It's equal to. Alright, so I put the numbers in between, and then I notice, oh, hey, by the -5 there's just a less than. So that means -5 is not included. And -1 would be included, because -1 is less than or equal to -1, right? It satisfies the or equal to part. So on the right end, I'm noticing less than or equal, so that means -1 is a solution. So I'd have an open point above -5 and a closed point above -1. And this is the graph I want to make back in the problem. And then if you wanted to do an interval, right, here's the picture of the solutions. Right, the left end is at -5, comma, the right end is at -1. -5 is not a solution, so I put a parentheses on that. -1 is a solution, so I put a bracket on that. But they didn't want this, right? They just want the graph. So let me put up that graph in this assignment here. Right? So again, from -5 to 1. So I move this one, the left end to -5. Right? I move the left end over to -5. I move the right end dot over to -1. Remember, the right end of the solutions was at -1. The left end, right? Remember, the left end of the graph at -5 had an open point. So an empty point, I just toggle this to empty. Right? See how it's an empty point now, an open point there. And then the right end was a filled in point, right? So I toggle this, move it up to filled. And this is exactly the same picture I drew a second ago, right? And that's it. So from -5 to -1, all the numbers in between, not including -5, but including -1. Submit that graph. Great. Right. And again, they show you the answer, have answer explanations, and all that. Alright, so moving along. Alright, now we're back to the objective. Solve a linear inequality that requires multiple steps to solve. So once again, I'll solve this, and then they want us to write the solution in interval notation. So I'll write this on paper and work on it on paper. Alright. So as I did with an earlier example, in this objective I'm going to simplify both sides first. So here I'm going to distribute this -5 to the quantity h minus 1 just to get rid of the parentheses. So we'd have 6h and then minus 5h plus 1, right? -5 times -1 would be, positive 5. -5 times -1 would be positive 5. Is less than or equal. And then the other side is, there are no like terms on the other side. That's as simplified as that side's getting. Then combining like terms over here, 6h minus 5h is 1h. And I got plus 5 is less than or equal to 7h minus 11. And then as I did in an earlier example, I like to move terms so that all the terms with the variable are on the left and all the terms without the variable are on the right. So I'm going to subtract the 7h. And I'm going to do that to both sides, get all the terms with h on the left, and then get rid of the 5 on the left here, subtract 5 from both sides. So now I have, h minus 7h is -6h. And all I did was subtraction, right? Adding and subtracting doesn't change the symbol, so this is still is less than or equal to. Then -11 minus 5 is -16. And then to get h alone, I would divide both sides by -6. Now, here is where the symbol would flip. Right? Here's where the symbol would flip, is when I multiply or divide both sides by a negative number, which I just did. So I've got h alone on the left. Now is less than or equal to becomes, is greater than or equal to. And then -16 divided by -6, a negative divided by a negative is positive. And 16 divided by 6, they have a common factor of 2. 2 goes into 16 8 times and 6 3 times. So that would reduce to 8/3. Right, 16 6 and positive, right? So here we go. There is a description of all the solutions of this inequality. I could replace h with any number greater than 8/3. Now 8/3 is 2 2/3. So I could replace h with 3, 4, 5, and whatever, and this would be true. Or equal to 8/3, right? So I could replace h with 8/3 itself, and the original statement would be true. Now if we're making a graph on a number line, 0, 8/3 would be to the right of 0. Right? And all the numbers greater than 8/3, right? So these numbers here to the right of 8/3 are solutions. 8/3 itself is also a solution, so a filled in point or a bracket, rectangular bracket above that. And now that I have a picture of all my solutions, I can write the interval notation pretty easily. So going from left to right, this picture of the solution set starts at 8/3 on the left, comma, doesn't end as you go to the right, right? It goes out to positive infinity. And then we cap them off, right? 8/3 is a solution. So I cap that off with a rectangular bracket to indicate that it is a solution. Infinity is not a number. You always put parentheses. And here's what they want, right? They want me to enter the solution set in interval notation. So that's what I'll go back and enter. Right? So we have rectangular bracket, and then 8/3, right? 8/3, 8/3, comma, and then positive infinity. And again, that symbol should be available to you here. Then a parentheses, right, on the right side, parentheses. Wonderful. Alright, so we continue on. Again, there'll be answer explanations and stuff. Please read those. Alright. Next part, we're back to the objective, graph an inequality on a number line and use interval notation. So this time we're given another one of those connected, compound inequalities where x is between two numbers, not including negative 1.3, but including 1.8, because you got the equal to on 1.8, but you don't have the equal to on negative 1.3. So once again, I'll write this out on a piece of paper, and we'll look at the graph, but then also, write what they want. They want it in interval notation, the solutions to this inequality. Okay. So like I said, the variable is all by itself in the middle, which is what you want for these connected inequalities. And the numbers that are solutions are numbers that satisfy both these inequalities, right? Numbers that are greater than negative 1.3 and at the same time less than or equal to 1.8. So when you see something like this, the solutions are numbers between negative 1.3 and positive 1.8. So again, if here was 0, negative 1.3 would be to the left of 0, positive 1.8 would be somewhere to the right of 0. And all the solutions are numbers between negative 1.3 and positive 1.8. And then negative 1.3 is not a solution to this, right? Because it doesn't satisfy the left inequality. Negative 1.3 is not less than negative 1.3, it's equal. So negative 1.3 itself is not a solution, meaning there's an open point or parentheses on negative 1.3. And then 1.8, the other end, would satisfy both, right? Negative 1.3 is less than 1.8, that's true. And at the same time, 1.8 is less than or equal to 1.8, right? It satisfies the equal part. So 1.8 would be a solution, and I'd put a filled in point over there, not an empty point, or a bracket. All right, and then we're asked to write this in interval notation, right? So looking at the picture of my solution set, going left to right, starts at negative 1.3, comma, and then the far, to the right end at 1.8. Negative 1.3 we stated was not a solution of this inequality, so I put parentheses on that to indicate that negative 1.3 is not a solution. And then the other end, 1.8, is a solution. We indicated that, and we indicate that with a bracket, right, the rectangular bracket. And this is what they want us to enter, right, the interval notation. So that's what I'll do back on the computer, right, back on the website. So on the left side, you got parentheses, and then negative 1.3, comma, 1.8, bracket. Right. And submit. And correct, I nailed it, hooray. All right. Moving on. So again, we're in that objective, graph an inequality on a number line, use interval notation. All right, so once again, I'll pull this on a piece of paper and we'll make the graph. Alright, so we're looking at negative 1 is less than x, and at the same time x is less than 4. So remember, this just means that, again, here's 0, negative 1 is to the left of 0, positive 4 is to the right of 0 somewhere. Remember, all the solutions to this inequality are the numbers between negative 1 and 4. And then you look at these endpoints. Negative 1 is not a solution to this because it doesn't satisfy the left inequality. Negative 1 is not less than negative 1. So put an open point, an empty point above that to indicate that negative 1 is not a solution. Doesn't make it true. And same thing with positive 4. Positive 4, that makes the left inequality correct. Negative 1 is less than 4, that's true. But positive 4 doesn't make the right inequality correct. 4 is not less than 4. 4 is equal to 4, and there's no equals sign here. Or, so again, on the other end, I also have an open point above positive 4. And if you were making interval notation for this, you'd be going from negative 1 to positive 4 with parentheses on both ends, because neither one of the end values is a solution, but everything in between is. But we're asked to make this graph. All right, and once again, it's one of those interactive things where, I move the left end point to negative 1. I move the right end point to positive 4. and then toggle both of these endpoints to be empty, right? And that there is exactly the same picture I drew, right? And submit. Wonderful. And it says, hey, when you're done with an objective, way to go, you completed it. And it tells you 1 of 3 objectives. I got 2 more objectives to finish. Alright, so next one. Back to this objective, solve a linear inequality that requires only 1 step. And again, we're asked to write the solution in interval notation. And here's this inequality. We're asked to solve for z. It's being multiplied by negative 24. All right, so to get z alone there on the left side, I would divide both sides by negative 24. And since I divided both sides by a negative number, this inequality symbol will flip around. It will change direction. Right? Again, when you multiply or divide both sides by a negative, that's when you change the direction of the inequality symbol. So we have z, and instead of is greater than or equal to, it'll be is less than or equal to. And then the right side, you have a negative number divided by another negative number. That's going to be a positive number. And then 13 over 24 doesn't simplify any further. So that's how I'm going to leave it. Positive 13/24. Right? There are no factors of 13. That, 13 doesn't go into 24 evenly. Nothing cancels. So there it is. A description of all the solutions of that original inequality. You could replace z with any number less than 13/24. So like 0, -1, -2, etc. Or equal to 13/24. And if you were making a graph of this, here's 0, 13/24 be to the right of 0. Right? It's actually between 0 and 1. And our solutions are all the numbers less than 13/24, right? So all these numbers to the left, or equal to 13/24. So 13/24 is included as a solution. So I put a filled-in point or a bracket above that. But they want interval notation, right? So I look at the picture of solutions going from left to right. There is no left end, so I indicate that with negative infinity, right? It goes off to the left forever. And then the right end of this solution set is at 13/24. And always parentheses on infinities. And we put 13/24. We said it was a solution to this, so put a rectangular bracket. And this is what they want us to enter, right? The interval notation describing this set of solutions to the inequality. So back on the page, that is what I will enter. So parentheses, negative, and then the infinity symbol, right? Comma, 13/24, right? 13/24, and then bracket, right? Because 13/24 is included. And submit. Pardon me. Great, great, great. Continuing on. Should have just a couple more left. Look at the mastery bar. I'm at 75%. So solve one of these one-step inequalities again. So once again, I'll write this out, and we'll solve it and write the answer in interval notation. All right. So here I'm solving for g. The only thing that I would need to do to get g alone is add 3/17 to both sides. And when you add or subtract, that does not change the symbol, right? So left side have g, still is less than or equal to. And then the right side is great because remember, when you add or subtract numbers, they need to have the same denominator. And these already have the same denominator. That would be the denominator of 17. And when you add or subtract numbers with the same denominator, that denominator is the denominator of their sum. And then you just combine the numerators, right? The numerator would be -13 plus 3. So I'm left with, -10 over 17. -10 17ths. And this is as simple as that fraction gets, right? The numerator and denominator have no common factors, so I'm done. The variable's alone, and I have a number on the other side that's totally simplified. So the solutions of this inequality, I could replace g with any number less than negative 10/17ths, right? So like -1, -2, -3, -4, numbers less than negative 10/17ths or equal to negative 10/17ths. That number should also work back in the original. And if you want to make a graph, you can. So here's 0. Now negative 10/17ths would be to the left of 0, right? Negative side. All the solutions are to the left, right, are less than negative 10/17ths, but also including negative 10/17ths. So I put a filled in point or a closed point or a bracket, rectangular bracket above negative 10/17ths. And then the interval for this, right, going left to right. There is no left end, so I indicate that with a minus infinity. And the right end of this solution set picture is at negative 10/17ths. And then you're always putting parentheses on the infinities. And then negative 10/17ths is going to have a bracket on it because it is a solution, right? Bracket means is, parentheses means it isn't. And this is what they want me to enter, right? The interval notation for this. So that's what I'll do back here. So we got parentheses, negative infinity, comma, negative 10/17ths, and then bracket, and then submit. Right? Wonderful. And now that objective is complete. All right, so I've got one objective left to finish, and then the assignment will be done. So it's that solve a linear inequality that requires multiple steps, right? So again, I'm going to write this out, we'll solve it, and again, we're asked to write the solution in interval notation. All right, so over on the left side, first I'll simplify the sides. We got this -5, right? -5, don't forget the minus. Can distribute the -5 to the quantity y plus 1. That'll give me y, and then you have -5y, and then -5, right? -5 times 1 is greater than or equal to 2y minus 5. And then y minus 5y, that's -4y. Then you have the -5 still, is greater than or equal to 2y minus 5. Alright, now comes the part where I move terms around, where I like to move all the terms with the variable to the left and terms without the variable to the right. So to do that, I'll subtract the 2y from the right side, and do it to the left side as well, subtract 2y, and then get rid of this -5 by adding 5. I'm going to add 5 to both sides. Alright, now after doing those operations, -4y minus 2y will have -6y on the left. And the symbol would stay the same because all I did was add and subtract. Right? Adding and subtracting doesn't change the symbol. Then the right side you have no y's, and then -5 plus 5 is 0. So I got the number 0 on the other side. Now in order to get y alone, I would need to divide by the -6. And I would do the same thing on the other side, divided by -6. Now this is a case where we will flip the symbol. Right? You are dividing both sides or multiplying both sides by a negative number. That's one of the cases where you flip the symbol around. Left side will be y, and then this is greater than or equal to becomes is less than or equal to. And then 0 divided by any non-zero number like this is just 0. So here we go. There's a description of all the solutions of this inequality. You could replace y back in the original statement with any number less than 0, so any negative number, and it should be true, or 0 itself. Replace y with 0 itself, and both sides will be, and this will be true as well. And if you make a graph on a number line, right, here's 0. All the solutions are values less than 0, right? So these values to the left of 0, and 0 itself. So a closed point, filled in point, or a bracket above 0. Then the interval notation for this, looking at the picture of the solutions going from left to right, well, there is no left end, so I indicate that with minus infinity, comma, and then the right end of this picture of solutions is at 0. Parentheses always on the infinities or negative infinities, because those aren't numbers. And 0 is a solution. Right? You had the less than or equal to. So I put a rectangular bracket on the 0, right? And this is the interval notation they wish for me to type in. And that's what I'll do. So here, parentheses, negative infinity, comma, 0, bracket, rectangular bracket. Wonderful. And I probably just got, based on the way the bar was filling up, I got one more question to do from this objective. Alright, so yes, the last objective, this should be the last one, right? It's 3/4 full, looks like. Solve a linear inequality that requires multiple steps to solve it. Again, now this one has a bunch of fractions, and if you don't like dealing with fractions, I'll show you a way you can get rid of the fractions. Right. Alright, so you notice all these denominators here, 4, 3, 12, and 12. One thing you can do is find the least common denominator, the LCD. What's the smallest number that all the denominators go into evenly? And I'm hoping you're seeing that that is 12 here. Right? 4 goes into 12 evenly, 3 goes into 12 evenly, and obviously 12 goes into 12 evenly. And then you can multiply both sides every single term. So every single term. Multiply both sides by this LCD. Alright, so let me show you what happens there. So I take the entire left side, the 3/4 q minus 2/3 q, and I multiply that side by this least common denominator, this 12. And there will be distributing, right, because there's more than one term. There are 2 terms on the left, so I need to multiply, I'm multiplying both of those terms by 12. And since I'm multiplying both sides by positive 12, the symbol, the inequality symbol, will not change, so this still is less than. And then I take the entire right side, 5/12 q, 5/12 times q, and then minus 1/12, and do the same thing. Multiply. If I multiply the left side by 12, I should be multiplying the right side by 12 as well. This LCD. And distributing the 12. There are multiple terms over here as well. Now the whole point of multiplying by the LCD, this least common denominator, is to get rid of the fractions, right? Each denominator goes into the LCD evenly. So for instance, left side, when I take 12 times 3/4, 4 goes into 12 3 times. 3 times 3 is 9. 3/4 times 12, that's 9. You'd have 9q for the first term over here. See how the fraction's gone. And we have minus. Then I do the same thing. 12 times 2/3 q. Well, 2/3 times 12 would be 8. Right? Because 3 goes into 12 4 times. 4 times 2 is 8. So I have 8q left there. So you see how the fractions are now gone, right? The denominators are gone. Is less than. And then in both of these, the 12s would cancel. And for the first term, I'd be left with just 5 times q. And then minus, and then this 12 times 1/12 would just be 1. And look at this inequality I have now. Right? After multiplying everything by the LCD, all the denominators are gone, and it's a much nicer looking equation or inequality. Alright, well this side here is just simply q, right? 9q minus 8q is just q is less than, then we have 5q minus 1. And as I like to do, right, get all the terms of the variable to one side, the left side here, I'm going to subtract 5q from both sides. Gives me negative 4q on the left is less than, and then just negative 1 on the right. And to get q alone, I divide both sides by negative 4, right, to get q by itself. And this is one of those scenarios where I'm going to have to flip the inequality symbol. Right? I'm dividing both sides by a negative number. So we have q on the left, and then is less than becomes is greater than, and a negative divided by a negative is positive. So this would be positive 1/4. And there we go. So the solutions of this inequality are all the numbers greater than 1/4. So plug in, a half, 1, 2, 2 1/3, right? Any number greater than 1/4 would satisfy the original inequality. And if you were to make a graph of this, right, here's 0, positive 1/4 is to the right of that somewhere. And all the numbers that are solutions are greater than 1/4, right? These numbers to the right of 1/4, but not equal to 1/4. So 1/4 is not a solution, right? I indicate that with an open point or an empty point or a parentheses. And then interval notation. Again, look at the picture of the solutions going left to right. It starts at 1/4, 1/4, comma, and has no right end, goes off to the right forever. I indicate that with a positive infinity. 1/4 is not a solution, so I put parentheses on that end. Infinity is not a number, so I put parentheses on that end, right? And here is what they're asking me for, right? Put the solution set in interval notation, and that's what I'll type in. So parentheses 1/4, comma, the infinity symbol, right? Positive infinity, parentheses, and there we go. Right, and that should be the end of the assignment. All right, correct, you nailed it. And then when I hit, continue, everything should be complete, right? And it says assignment is, now again, you're not going to see the word preview, but the assignment is complete, and you can close the tab and be done. All right, so like I said at the top of the video, the questions I saw aren't going to be exactly the same as the questions you see. Some of them might, but the objectives are all the same, and the way I did some of these problems are all going to be the same. All right, so hopefully watching me go through this assignment here helps you when you're working on, section 2.5's Knewton Alta assignment on your own. And thank you very much for watching.